Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 552 contiguous array. Okay, so first let's try to understand the problem statement, and after that we will see the approach how to solve this problem. So given a binary array nums, return the maximum length of a contiguous array with an equal number of zeros and one. So in the problem statement says that we have given one array names and we have to return the maximum contiguous subarray in which the number of zeros is equal to number of ones. Okay, suppose if we take this example, then we have number of zeros is equal to 1 and 1 occur one time, so the maximum length of subarray is equal to 2. If I consider this example, then if I consider this contiguous subpart, that is 0 1 or either 1 0, then both have contiguous subarray and both have equal number of zeros and ones, so the answer will be 2. Let's now understand this question in a better way in the whiteboard. Okay, so in the problem statement, as mentioned, that we have given a nums array that consists of only zeros and one, and the problem statement says that we have to find the maximum length. Okay, maximum length of contiguous subarray which contain equal number of zeros and one. So if I consider this example, then if you try to check the length of the contiguous subarray that has equal number of ones and zero is, suppose if we take these things, that if I consider this subarray, this subarray has maximum length, that is 6, that contain equal number of zeros and equal number 1, that is 3 1 and 3 0. Okay, so we have to return these things, that what is the length of the subarray, that contain equal number of zeros and 1. So actually this problem is little bit tricky. So I think you all have solved one problem, that is we have given, suppose we have given a array that is 10 5 2 7 1 9, and we have also given a target, suppose let's say k is equal to 15, and in this problem statement it says that find the length of the maximum contiguous subarray whose sum is equal to 15. If you solve this problem, then this problem is a cakewalk. So first try to understand how to solve this problem. Suppose if I wanted to make the answer, then the answer will be the question will be, we have to find the maximum contiguous subarray that gives the sum is equal to 15. So first subarray is this much and length of the subarray is 2. Okay, and whether the any other subarray exists, so let's check. One other subarray exists that gives 15 is this thing, 52711, so the length is equal to 4. So we have to return the maximum length that gives the 15, so in this case we have to return the answer is equal to 4. Okay, so first let's understand how to solve this problem, that is we have given a subarray and also given a target, and we have to return the maximum length of the contiguous subarray that gives the value given target. So let's first try to understand this problem, that how to solve this problem. So this problem will be solved with the help of one method of solving this problem is, if you try to all the possible subarray, and if I make the sum of all subarray and after that we return the maximum length, okay, then it takes big O of n squared time complexity. So it is a brute force approach, but it is a bad complexity. We have to optimize this. So if I take the unordered map, if I take unordered data structure that contain the previous summary, let's see how this happens. Suppose we take a data structure, okay, data structure unordered map of int. Okay, so first what we need to do, suppose we calculate the contiguous subarray. Suppose the takes one variable sum. Initially if I is equal to 0, then sum is equal to 0, and check whether in the map 10 exists or not. If not exist, then put the 10 as a key, and also make the index at which index the 10 should be found. So index is equal to 0. If I try to write the index, then index will be 1 0 1 2 3 4 5. Similarly, if I take this one also, so the sum will be increased to 15, and after that we check whether the 15 will be matched with the target value or not. If target value is mapped, then what are the length, then length should be increased to 2, because we get a subarray that sum is equal to target and length is equal to 2, so length should be increased by 2, and after that check whether 15 should be exist in the map or not. No, it is not exist, so take the 15 value and put it in with the index number, so index is 1. After that we calculate these things, so this occurs as the 17. So sum is equal to 17, and then check whether the sum is equal to target. No, not is equal to target. Then check whether 17 exists in the unordered map. So no, 17 not exists, so put 17 in the unordered map, or also put the at which index 20 should be found. So add two index. If I take these things, then sum should be updated to 24. Okay, sum should be updated to 24. Okay, so first of all check whether 24 is equal to target or not. So no, target not is equal to target, so length should not be updated. Okay, and after that we check whether in the map 24 exists or not. No, 24 not exists, so put at which index 24 will be exist. And if I take these things, though, now the sums will be updated to 25, and check whether 25 is equal to target exist or not. So no, then put the 25 in the map, and also at which index they should be found. So at this point, if I find suppose we take that thing, suppose let's try to understand in little better way. Okay, so at this stage we get 25 till here at index 4, and also the if the k value is, if I take the k value is 15. Okay, so if I subtract 25 minus 15, then check whether 10 will be exist in the map or not. So here 10 will be exist, so it make sure that 10 will, if 10 will be exist, then there exist another subarray of different length. Suppose we take at that index we get 25. Okay, we get sum is equal to 25, and also 10 in is exist till here. So if I consider this part, then we get the 24 minus this part, sum is equal to 15, because till here we get 25 and till here we get 10, so this one gives the 15 length. So if 25, that is whatever the sum minus whatever the k, that is the target, exist in the map, if exist in the map, then we update the max length is equal to maximum of whatever the max length, and also whatever the index of these things. Okay, so index of these things is 0, so update these things with maximum of whatever 25 minus 15. So if we get if the sum minus target is exist in the map, then it makes sure that some another array will be exist, another contiguous sub array will be exist in the map. So we have to check that condition as well. So in this way we have to solve this problem and we get the desired answer, that what are the length of the maximum subarray which give the target is equal to k. So let's try to summarize this approach. So in this approach we have given a rate 10, 5, 2, 7, 1, 9, and we have also given a k value is equal to 15. Okay, k value is equal to 15. So in this approach, first we iterate the loop from I is equal to 0 to n. Okay, and after that we calculate the contiguous subarray, that is array of I. Okay, and then check if sum exists in the map or not. If not exist, then put the sum as a key or index in the map, and also check that if sum minus k exists in the map or not. If exists, then max length is updated as max length is updated as whatever the maximum length, and also subtract the value I, that is at this index I is equal to 4 minus at which index this value is found. So this value is found as sum minus k. So and after that we return the max length. Okay, so this is the approach of solving this problem. So this problem I will be solved using this approach. Okay, so suppose what I did in this case, we have given a binary array. Okay, binary array, and if I modify this array little bit, suppose if we modify 0 is equal to -1 and 0 is equal to -1 and 1 is 1 we take as it is, and 0 is replaced by -1. If minus replaced by -1, then now the question will be reduced to as that find the maximum length of contiguous subarray that gives sum is equal to 0. Okay, so after modifying the array, the question will be changed like that. After replacing 0 is equal to -1, then question will be reduced as find the maximum length of contiguous subarray gives the sum is equal to 0. So in this question we have also given an array and also given a target, and in this question also we have given an array and here the target is equal to 0. Target is equal to 0. So if similarly, if we approach this problem now with the help of this problem, then you will able to solve this approach. Only the target value will be changed is equal to 0. So where the k value exists in this question, we will replace k is equal to 0. Then we are able to find the maximum length. Maximum length that contains equal number of zeros and 1. So I hope you all guys understand the problem statement, that how we will approach the problem. So let's summarize the problem statement. So we have nothing to do. We take the reference from this problem, that find the maximum length of subarray with a given target, contiguous subarray. So we will modify this problem statement as we replace 0 is equal to -1, and after that we will find the maximum length of contiguous subarray that gives the sum is equal to 5. So here we see the maximum length of this subarray that gives the sum is equal to 0. So we have to return that length. So let's try to see the code, that how we will approach this code. So let's understand the coding part. Okay, so coding part will be very easy. So let's see what I will do in the coding section. So first find the length of the array, and after that we modify the array little bit. Whenever we get 0 at that index, we replace 0 is equal to -1, and after that the problem statement will be reduced to this, that find the maximum length of subarray which gives the sum is equal to 0, that is target is equal to 0. So take the max length as int min, and after that make a sum and take the unordered map that keep track of if the previous sum minus target exists or not. If exists, then there must be any survey exist in the back section. So this map take care of that things. Okay, and after that we iterate the loop and find the sum, and after that check if sum is equal to 0. Here 0 is the target because the target will be reduced to 0. If sum is equal to 0, then max length is updated to I plus 1. Why I plus 1? In the array b move from I is equal to 0, but in the original length b make sure that the I will be moved from 1. So for that reason b take I plus 1, and after that we check if that sum will be exist in the map or not. If not exist, then put in the map and also make sure put the index, and after that we also check the if here we do sum minus k, but the and also we check whether the sum minus k exists or not. So here k is equal to 0, so here nothing we will write. After that find then update that max length with I minus map at which index that exists, like sum minus k exists, and after that we return the max length. Okay, so I hope you all guys understand this problem statement. So if you try to submit this code, then you will get correct result. So let's try to run for the test case number 1. See, it will accepted, and if you try to submit for all the test cases, then it will be correct for all the test cases. So yeah, it will be accepted. So hope you guys understand the question. So thank you for watching the video. See you in the next video.